Pre-calculus, section 2.2, quadratic functions. Objectives. Recognize characteristics of parabolas, graph parabolas. Determine a quadratic function's minimum or maximum value. Solve problems involving a quadratic function's minimum or maximum value. Quadratic functions make graphs called parabolas. Parabolas have a turnaround point called a vertex. The x-coordinate of the vertex is the equation of the line of symmetry, or the axis of symmetry. So if I graphed a nice parabola here, we would see that there is a mirror-like line where this point is equal distance away from that point with respect to that line. So in a way, we can get away with knowing a few points and our axis of symmetry to graph parabolas instead of needing to know a whole bunch of points, which people have done in the past. The standard form of a quadratic function, the quadratic function f of x is equal to a times the quantity of x minus h squared plus k, where a is not equal to 0. If our a was equal to 0, we just have f of x is equal to k. And this is the standard form. The graph of f is a parabola whose vertex is the point h comma k. So we just recently saw this with circles, where we had this h. Over here we have our k, which doesn't have a y this time, but that's okay. We'll get more of that later, actually. The parabola is symmetric with respect to the line x is equal to h. So that right there is your AOS, your axis of symmetry. If a is greater than 0, the parabola opens upwards. If a is less than 0, the parabola opens downwards. Here are some steps on how to graph a quadratic equation. So to graph f of x is equal to a times the quantity of x minus h squared plus k. First, determine whether the parabola opens upwards or downwards. Is your a positive or is your a negative? Determine the vertex, which is your h comma k. Find any intercepts, x-intercepts, by solving f of x equals 0. This one sometimes isn't the easiest one to do because you might not have real values for x-intercepts. You might have imaginary ones, the previous section. Find the y-intercept by computing f of 0. So we replace our x's with a 0. This one we for sure can do, and I will do every time. Plot the intercepts, the vertex, and additional points as necessary. We may need to plot additional points. And then connect them with a smooth curve like a bowl or an inverted bowl. All right, so let's graph one of these. So here we're going to have our graph. We have a parabola. We have an a, which is 3. Our 3 is positive. Since our 3 is positive, we know it's going to be opening upwards. Here our h comma k is going to be equal to a 2 comma negative 12. With parabolas, our k is exactly the number that you see it. And our h is once again the opposite of whatever's inside of the parentheses. And I'm going to go ahead, I'm going to change this paper a little bit because 12, I can tell you right now, is going to be quite far down. All right, so let's just start off by graphing our vertex. So that's 2 in the x and negative 12 down. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we'll get a point right there, and that is our axis of symmetry. So I'm going to make this invisible line here. Yes, you can see it, but it doesn't actually belong there. It's not part of the graph, but it's a tool for us. And we know that what we plot on the left of it will also be on the right of it. What we plot on the right of it will also be on the left of it. So let's go ahead and find our intercepts. So I'm going to say 0 is equal to 3 times x minus 2 squared minus 12. I'm going to add 12 to both sides. A little bit of a shortcut here. So we can get 12 is equal to 3 times x minus 2 squared. I'm going to divide both sides by 3. And get 4 is equal to x minus 2 squared. Now I'm going to take the square root of both sides and get two equations now. Negative 2 on the left here is equal to x minus 2. And then a positive 2 is equal to x minus 2. Because square roots, you get both positives and negatives. We're going to get both positives and negatives. So the one on the left now, I'm going to go ahead and add 2 to both sides. And get x is equal to 0 is one of our x-intercepts. And then for the other one, adding 2 to both sides, we're going to get x is equal to 4. So let's go ahead and plot those points. So we're going to get 0. I'll do that in pink. And then the other one is going to be at 4. So in this case, I don't need to plot any y-intercepts because we already have it. It's at the x is equal to 0. And then we'll try to graph this with a smooth curve. It's kind of really skinny here, but there we go. All right, so once again, we're going to graph this. So first off, let's find our h comma k. H comma k is equal to 1 comma negative 3. Let's see, if we say 0 is equal to negative x minus 1 squared minus 3, we're going to get, if we add 3 to both sides, 3 is equal to negative x minus 1 squared. Divide both sides by negative. We're going to get, I'll move it over a little bit, negative 3 is equal to x minus 1 squared. And here's where we're going to stop because we're not going to get a real solution here. So in this case, our graph will not be crossing our x-axis because we don't have any x-intercepts because they're not real, they're imaginary. So the next thing to do here is do our f of 0, which I did not do on the previous one because it was kind of given to us by finding our x-intercepts. So our f of 0 is going to be equal to a negative 0 minus 1 squared minus 3, which is going to be a negative 1 squared minus 3, which will give us a negative 4. Do the math. So then what we have here is a graph. Let's see, we have some negatives here, so I'm going to go ahead and graph it a little bit higher. A little bit to the side because our vertex is at positive 1. All right, so our vertex is 1, negative 3, so that's going to be this point right here. We're going to have that axis of symmetry, which once again, it's not actually there, but it's kind of a tool. I'm going to actually use it this time. And then at our x is equal to 0, our y-intercept, we're going to get our y is equal to negative 4. And since we have a dot 1 to the left of the axis of symmetry. We're going to also have a line 1 to the right of it. And we may decide to plot more points because this could be really any parabola, but that was just a sketch. All right. So we don't always have a parabola in the nice form that we had earlier. Sometimes we have it in the form of f of x is equal to ax squared plus bx plus c. So in this case, here's the trick. Our vertex can be found by computing this. So that will give us our x, the opposite of b over 2a. If that at all looks familiar, take a look at this. X is equal to the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. If we take this portion right here, hey, look at that. That right there is your vertex. And you thought it was just to find intercepts. Okay. Then if we take that value right there and we plug it into our function, plug it into all of our x's, we get the y value for our vertex also. That's basically what all those words are saying. Let's go ahead and apply this. Oh, never mind. Let's read a bunch of more words. Okay, so to graph something in this form, once again, determine your A. Your A is nice. If your A is still positive, it'll open upwards. If your A is negative, it'll open downwards. Determine the vertex from the formula that we got earlier in the previous slide. Find any x-intercepts by solving f of x is equal to 0. Set your y equal to 0. We only care about the real solutions. Find any y-intercepts. Okay, so these last two have been the same by computing f of 0. And in this case, so here's where this one becomes a little bit nice. 100% of the time, your y-intercept is just this c, so you don't have to do any math. When you plug 0 into your x, that disappears and that disappears, so you just get f of x is equal to c. All right, and then plot intercepts, vertex, and any additional points as needed. Example 3. Here we go. So right away, I'm going to just kind of jump in there. I'm going to say that we're going to get a y-intercept at 0, 9, because that's what our c is. All right, if you looked at my factoring strategies cheat sheet that I gave you, we would see that this ends up becoming an x minus 3 squared. So we're going to get x-intercepts at 3. So we're going to get our x-intercept at 3, 0, because we do x minus 3 equals 0, x equals 3. We just need a vertex now. So our vertex is going to be at x is equal to the opposite of b, so that's going to be a 6 over 2 times our a, which is 1. So we get x is equal to 6 over 2. Or x is equal to 3. Hey, look at that. It looks like our vertex is going to be our x-intercept. Let's just prove it. So we're going to get f of 3 is equal to 3 squared. Already doing math. Minus 6 times 3 plus 9. Which is a 9 minus 18 plus 9, which is simply just 0. Okay, cool. Graphing it. We're done. Moving on. Okay, our y-intercept's kind of big, so I'm going to go ahead and graph mine kind of downwards. And let's see. Do this right here. So our vertex is 0, 3. Our axis of symmetry goes straight up through there. Once again, it's just a tool. It's not actually part of the graph. And then 1, 2, 3, 4, 5, 6, 7, 8, 9. Perfect. I have enough space. So if I move over 3 onto the other side, I get my parabola, which I didn't connect the dots. Okay, that's supposed to be smooth, folks. All right, maximum and minimum. So our vertex is our turnaround point. So if we have a parabola pointing upwards, we have a minimum at the bottom. The arrows keep going up forever, so there is no maximum. It goes on to infinity. If we have an upside down parabola, we have a max. Well, this one happens when your a is positive, and this one happens when your a is negative. So that's all this is saying here. And the rest of it is just saying, well, calculate your vertex, and it'll give you the x at which your minimum happens, and then the value. So x is equal to the opposite of b over 2a, and then the value, because you might have some word problems, is equal to your f evaluated at the opposite of b over 2a. So this is the where. And then our y, I guess I should say, is the value. So just keep that in mind. Where is x and the value is the y. Some keywords there. All right. So considering the quadratic function, 2x squared plus 8x minus 14, determine without graphing whether the function has a minimum or a maximum value. Well, our a is positive. So for a, we're going to have a minimum because we have a parabola which goes up like this. B, find the min slash max and determine where it occurs. Okay, so the where is our x, and then the min slash max is the y. So our x will be equal to the opposite of b, so that's going to be negative 8 over 2 times 2 over 2a, or the x is simply just a negative 2, because that's an 8 divided by 4, which just gives you negative 2. Where it happens will be the y. So our y is going to be equal to 2 times negative 2 squared plus 8 times negative 2 minus 14. Some more room here. So that's going to be, check the math, it's going to be an 8 minus 16 minus 14, or a negative 8 minus 14, and now I need to use my fingers, 14, 15, 16, 17, 18, 19, 20, 21, 22, or just negative 22. Identify the function's domain and range. Okay, so C is going to be kind of the easy part. It's a parabola. The domain is negative infinity, comma, infinity. That's the domain. The range, well, we know we have a minimum value. So that means our where is going to be our minimum. So we're going to get for our range, I know I should have did the other one the other way. It's going to be a negative 22. Since it's a minimum, it's going to go up forever. And I should make that a square bracket, not a parenthesis. Ooh, projectile motion. Okay. In general mechanics, a particle, such as a rock, a ball, a water balloon, that undergoes projectile motion will exhibit heights. I guess I didn't fix that one. Okay. When thrown at an initial height of 1.8 meters, and initial upward speed of 5 meters per second, can be described by this equation here. Determine the maximum height of the particle. Okay, so here we know our a is negative. We have a negative 4.9. So then that means we need to find out first where this happens. So our t for a is going to be equal to the opposite of b, so negative 5 over 2a. So it's going to be a 2 times 9.8, and there should be a negative there. T is being time here, so our t is equal to, and now I need a calculator. And here we're going to get 5 divided by, I did the math already for you. It's supposed to be a 4.9. Sorry, folks, I accidentally hit the microphone. Divided by a 2 times 4.9, close parenthesis, enter. All right, so I'm going to get my t is approximately 0.51 seconds. Now plugging that in, we're going to get that our height is going of 0.51 seconds will be equal to a negative 4.9 times 0.51 squared plus 5 times 0.51 plus 1.8. So let's go and do that. Minus or negative 4.9 times 0.51 squared plus 5 times 5.1 plus 1.8. I'm going to get that the maximum height is going to be equal to about 26 meters. All right, when does the particle first reach 2 meters in the air? All right, that one's going to take some work. So in this case, we're going to say for C, 2, which is our height, is equal to negative 4.9 t squared plus 5t plus 1.8. All right, I'm going to subtract 2 from both sides of the equation and then get 0 is equal to negative 4.9 t squared plus 5t and then 0.8. Negative 0.2. Let's just double check. 1.8 minus 2. Yeah. All right. Quadratic formula. I mean, it's not what I want to do, but it's what we're going to do. All right, let's zoom in here. So the opposite of b, so we get a negative 5 plus or minus the square root of 25 minus 4 times negative 4.9 for AC. Okay, which gives us a, plugging into there, a negative 0.2. I was thinking about that for a second. I thought too long. Forget about it. Okay, all over 2 times A, which is negative 4.9. Let's see, first off, 2 times 4.9 is, yes, 9.8, which is gravity. Negative 5 plus or minus square root of 25. I'm going to go ahead and calculate the rest of this. So negative 4 times negative 4.9 times negative 0.2. Okay, I get a negative 3.92, so I can take the square root of that. forgot a calculator, folks. Okay, so then let's go ahead and do that. Square root of 25 minus negative 3.92. 3.92. I get an ugly number, but it's a number, so we get negative 5. That's supposed to be negative 9.8. I'm going to take the negative because I know it's going to work, because on the bottom I've got a negative. So I want the first one, so that's going to be, well, let's do them both. Okay, we get a 4.59, so then negative 5 minus 4.59. So I either get a negative 9.59 over 9.8, or I get negative 5 plus 4.59, which is a, I think that one's the answer actually, negative 0.41 over 9.8. Negative 9.8 for both of those, so they're actually positive, and then, oops, doing two divided bys. Okay, so the first one I get, because it's the smaller number, first one will be the smaller number, is t is equal to 0.04 seconds. I know that's going to be the second one because that's a bigger number. Bigger number means later time. All right, let's finish this. Holy goodness, there's a lot more words. Okay. Strategy for solving problems, maximizing. All right, read the problem carefully and decide which quantity is to be maximized or minimized. Use conditions of the problem to express the quantity as a function in one variable. Rewrite the function in the form of f of x is equal to ax squared plus bx plus c. Calculate your vertex, then answer the question posed in the problem. All right. So among all pairs of numbers whose difference is 25, so we're going to get x minus y equals 25. Find a pair whose product is as small as possible. So we're looking for something where your x times y is equal to something small. I'm just going to put P for product. So we want to write this as one variable. So I'm going to go ahead and change this. I'm going to add y to both sides and get x is equal to 25 plus y. I can now take this and plug it in and get x times 20. Oh, actually I want y. Y times y plus 25 is equal to p. And then we will distribute. So we'll get a y squared plus 25y plus 0 is equal to p. And we just find our vertex now. Okay. Well, actually, we will set this equal to 0 because we want to minimize it. And then we'll solve. So here our a equals 1, our b is equal to 25. So then our y will just be equal to, yes, it's y, because we have y's here, not x's. It's okay. Deal with it. We can plug it back in and find out what x is. Y is going to be equal to the opposite of b, so negative 25 all over 2 times a, so that's going to be a 2, or just a negative 12.5. Cool. Plugging that back in, we can get x is equal to 25 minus 12.5, or x is equal to a 12.5. All right, so the two numbers are x is equal to 12.5 and y is equal to negative 12.5. Cool. All right, last example. You have a 200 yards of fencing to enclose a rectangular region. Find the dimensions of the rectangle that maximize the enclosed area. Okay, so 2x plus 2y equals 200. Why? Because you have fences, and this is how you calculate perimeter. You're going to have two sides with length x, two sides with length y, and if you add them all together, they equal to be 200. Area, so we're going to get a is equal to x times y. So same kind of thing here. This I'm going to subtract my x's. So I'm going to get 2y is equal to 200 minus 2x, or y is equal to 100 minus x. Plug that into the area. 0 is equal to x times x, nope, 100 minus x, or 0 is equal to 100x minus x squared, but we want this to be negative x squared plus 100x, and then we just solve and find, and good day. Okay. So our h will be equal to the opposite of b, so negative 100 over 2 times a, so that's going to be a negative 2. H is equal to 50. Cool. Now that we know that, plug that in, and we get our k is equal to 100 minus 50, or this is just a 50 also. So in this case, equal sides. We will maximize the distance in, or the area, if our h and our k, our x and our y, are equal to each other.